Now let's determine both these limits. And the first one we have limit as x approaches 3 of 1 over x minus 3. So I'm just going to quickly draw this function actually. We have an asymptote here at x equals 3. And why is that? Because, well, if we were to plug in 3 for x, we would get 0 down below. So that gives us an asymptote. And the rest of the function is just going to look like this. Let me see if I can do a quick yet good job at drawing this function. I hope I can. And what we're going to be doing, of course, is then we're going to visualize the answer to the limit. A graphical approach is not a bad idea, especially right now because I want everyone to visualize exactly what I'm doing and why the limit's going to be what it is. And there we go. That's not that bad a job, right? So yes, these lines represent 1 over x minus 3. So we want to determine, of course, the limit as x approaches 3. Here's the funny thing though. We need to determine the limit as x approaches 3 from the right of 1 over x minus 3, and that would be just positive infinity. If you have watched our intro video, that should make sense, because as we approach 3 from the right, this is x equals 3, so as we're approaching 3, this is just skyrocketing. The function is just going straight up. So that's just going to be infinity, positive infinity. What if we're looking for the limit as x approaches 3 from the left? Well, here's a function, and as we approach 3 from the left, it just takes a free fall. And the limit will actually be negative infinity. And do you recall what happens when the limit as x approaches 3 from the right? The limit as x approaches 3 from the left will indicate, when we're trying to determine the limit as x approaches 3 for this function, well, it just won't exist, since the limits coming from the right and the left are just different. So this guy, this limit, does not exist. Now, how about question 2 though? Let me just make myself some room, or give myself some room. This should be quick. There we go. And I won't need to actually graph this to figure out the answer. For the limit as x approaches infinity, for 5x minus 8 over x minus 3, what I'll do is that I'll multiply denominator and numerator by 1 over x. And why 1 over x? Because I just want to essentially cancel out the highest power of x, which in this case is just 1, in the denominator. If this was x squared, or if this were x squared, I put 1 over x squared over here and over there as well. And let's see what's going to happen. We're going to have 5x times 1 over x, which is just 5. I need to distribute this, right? And actually, let me take it even slower. 5x times 1 over x is 5x over x. Negative 8 times 1 over x is just minus 8 over x all over. Now I can distribute x. X times 1 over x is x over x. And negative 3 times 1 over x, or sorry, that's actually minus 3. Minus 3 times 1 over x, minus 3 over x. Essentially, when we're multiplying the number by the fraction, of course, we just multiply the top, right? And right now, I can cancel these things out. the x's go away. We get a 1 down at the bottom. So essentially we just have limit as x approaches infinity of 5 minus 8 over x all over 1 minus 3 over x. And now of course comes the fun part. We can essentially break the limit down and apply limit as x approaches infinity to each element of the limit according to limit laws. So this part takes a little while, of course, because we have to rewrite the limit several times. 4 times to be precise in this case. Lim as x approaches infinity for 1 minus limit as x approaches infinity for 3 over x. Okay, so now let's take a look at this guy. What is the limit as x approaches infinity for 5? That's just 5. Now, the limit as x approaches infinity for 8 over x is just 0. Every time that we have a limit as x approaches infinity or negative infinity for a constant over x or x squared or x cubed, we're just going to have 0 all over. Now, the limit as x approaches infinity for 1 is just 1. And just like the top one, limit as x approaches infinity for 3 over x is just 0 as well. So we end up with 5 over 1, which is equal to 5. That's it. And we're done questions 1 and 2.